So what we're going to do is we're going to generate matrices that will allow us to do elementary row operations that we use in Gaussian elimination. This is going to become really important when we start looking at developing the inverse for a matrix or actually writing the matrix itself as a product of elementary row operations. The first one we're going to look at is permutation matrices. And so what a permutation matrix is, just as a review, is we'll take this matrix, say for example we have 1, 2, 3, 4. Okay, and what we want to do is we want to permute row 1 and 2. So that's going to give me, okay, 3, 4, 1, 2. Now, how we're going to do that is I can do that utilizing multiplication on the left-hand side with an elementary row matrix. And so what that's going to do is that's going to actually flip my two columns. So now I'm going to have 0, 1, 1, 0, all right? And that's the elementary row matrix that will allow me to do this. So let's just check and make sure that that's the case. So I take 0, 1, 1, 0, okay, multiply it by 1, 2, 3, 4. I get 3, 4, 1, right, and 2. And there you go. And it's permuted the first and second rows. Now, what if we have a larger matrix? Okay, let's say for example I have a 3 by 3 now. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and what I want to do is I want to permute the first and third columns, or first and third rows, excuse me. And this is now, we know that this is going to become 7, 8, 9, 4, 5, 6, 1, 2, 3. Well, what we're going to do, our elementary row matrix, okay, is going to be the matrix, it's going to be the identity matrix, except what it's going to have is its first and third columns switched or permuted. So this is going to be 0, 0, 1, 0, 1, 0, 1, 0, 0. And just to show that this is in fact going to give us exactly what we want, we'll multiply that by 1, 3, 5, 6, 7, 8, 9. Okay, and you can see just utilizing some matrix multiplication that we end up with 7, 8, 9, 4, 5, 6, and 1, 2, 3. Okay, so basically the permutation matrix, what it does is we have Pij, so that's our permutation, our elementary row operation. That permutes the ith column, ith row, and jth row. All right, it's going to be the matrix, right? The identity matrix with the ith and jth column switched. Okay, and that's it. All right, so an identity matrix, right, has to be the right size, and then it'll have the ith and jth column switched. You know what we should also add in? Let's actually do one more and show that you in fact don't need a square matrix in order to do this. You just need the right size matrix. So let's say for example I have 2, 3, 4, 5, 6, and what I want to do is I want to permute, okay, the first and second rows. So that means I want to go to 4, 5, 6, 1, 2, 3. I'm going to use now, all right, I'm going to think about, okay, well, what size does my matrix have to be? Well, my matrix is going to have to be a 2 by 2, 2 by 2 identity, okay? So 2 by 2 identity with the column switched, 3, 4, 5, 6, and after multiplication, that's going to end up equaling 4, 5, 6, 1, 2, 3. All right. So when you're constructing a permutation matrix, and with any elementary row matrix, make sure that you have the right size matrix that you'll multiply by, and then we're just going to be permuting or switching the columns that correspond to the rows that you want to switch in the original matrix. All right, and that concludes it.